Greetings, my name is Jacob Lopez and my research partner is Adama Barro. Our mentor is Professor Daeho Kang, PhD, and our major is Environmental Controls Technology. I would like to give credit to Cathal O'Toole, Matthew Quinones, and Shireen Moore for collaborating in previous research. The title of our project is Preventing Transmission of COVID-19 in HVAC Systems, Implementation of HVAC Design Upgrade. And now, my partner Adama Barro will introduce the research.
Hello, everyone. As an introduction, as schools, government buildings, and commercial facilities of all sorts were shut down due to last year's COVID-19 pandemic, the urgency to focus on indoor air quality has been a priority to communities of all respect. In order for our research to be successfully in finding mitigation strategy for SARS-CoV-2 coronavirus, we first had to address the nature of how the virus may transmit through the air in public indoor spaces. There was an initial thought that the spray and circulation of this airborne pathogen could be potentially due to air conditioning duct system. So our main focus was to advance our knowledge on HVAC system by researching proven engineering method and guidance. In our previous project, we researched how COVID-19 can possibly flow through the ambient air inside of restaurant, office spaces, and locomotive train cabins. In a research article titled Evidence for Probable Aerosol Transmission of SARS-CoV-2 in Poorly Ventilated Restaurant by corresponding author Kang, we learned that computational fluid dynamic simulation software was used to predict how viral particulates disperse and travel through the air.
Here is an image of computational fluid dynamics. Here, figure 1 shows the computational fluid dynamics study on airflow in a restaurant, and figure 2 shows computational fluid dynamics, which is basically tracing the image of the gases.
Understanding of aerosol transmission of COVID-19 in indoor environments. In the case with the poorly ventilated restaurant, the computational fluid dynamic data on the ventilation rate was found to be between 1.58 CFM and 2.2 CFM of ventilation per person. According to the ASHRAE, acceptable in the ventilation per person should be 15 CFM. Results from this study concluded that reasons for virus transmission in poor ventilation and had inadequate fresh air exchange. Approaches to mitigation. In order to find out how improve air diffusion in indoor spaces, we continued to study research article and paper which has led to learning about the proven engineering methods and applications that are currently being used to mitigate the transmission of the virus in the supply air and indoor air. These engineering methods include practical solution for source control and operational control measures that can be applied.
Source control, ultraviolet UVC. The band of electromagnetic radiation, which is UV light, can be classified into 4 wavelengths: UVA, UVB, UVC, and the UV vacuum. It has been found to show that wavelengths 100 through 200 nanometers are germicidal. In the research paper titled Ultraviolet Germicidal Irradiation Handbook, UVGI for Air and Surface Disinfection by Władysław Kowalski, it has been found that at wavelength 253.7 nanometers, which falls under the UVC spectrum, changes occur in the structure of DNA and RNA, which results in the inactivation of RNA viruses. Here is an image of various MERV rated filters. It's basically used as a source control. Various filter ratings, you can compare the filter's performance according to different criteria. And as you can see, MERV 13 can also filter virus carriers.
Source control, minimum efficiency rated value, MERV 13 filters. According to research, SARS-CoV-2 virus is 0.1 microns, but 1 micron or larger when trapped in respiratory droplet nucleus. Higher rated MERV filters are more efficient in capturing small particles. Research suggests MERV 13 filter is the least resistant to airflow, 85% efficiency in capturing COVID-19 particulates at 1 to 3 microns range.
Here we have source control strategies. Figure 4 shows the UVC lamp fixtures installed upstream and downstream the cooling coils, which disinfects the airstreams and the cooling coils. And here we have figure 5, which shows the MERV 13 air filter, which can be used to improve the air quality of school buses and mass transit vehicles.
Engineering guidelines, source control. Research has shown that UVC germicidal irradiation lamps inactivate 99% of virus and minimum efficiency reporting value MERV 13 rated filter were 85% efficient at capturing COVID-19 particles that range from 1 to 3 micrometers in size. Operational control, displacement ventilation extract contaminated air at ceiling high by creating a negative pressure vacuum. When analyzing and comparing zone air distribution effectiveness, research has shown that displacement ventilation performs 1.3 times better at improving air quality than with just using mixed air ventilation.
Here's an image of ventilation displacement, which shows how the air moves in a classroom setting. UV lamp performance efficiency. As we continued our research project, we focused on assessing the effectiveness of in-duct ultraviolet UVC lamp irradiation and ideal installation arrays according to the latest research and mechanical engineering guidelines. Figure 6 shows the lamp array configurations. Modeling methods. Computational fluid dynamics simulations tests have been used as one of the major tools for modeling the effectiveness of ultraviolet germicidal irradiation. In this research, the discrete ordinances method was used to model the irradiation field of UVGI systems. In order to test the best ultraviolet lamp array configuration, 4 identical UV lamps were distributed evenly in 4 different arrangements. They were arranged in a vertical, horizontal, and 30-degree diagonally in a counterclockwise array inside of the ventilation duct that measured 2 feet wide, 2 feet high, and 25.6 feet in length. The pathogen-containing particles were injected at the supply inlet, which would be used as the experimental viral sample. This is how the dispersion of the particulates can be monitored when interacting with airflow turbulences. Figure 7 shows the UV radiation contour profiles at midplane for all cases. UV lamp performance efficiency. It is important to note that lamp array position plays an important factor in UV performance. Different lamps array configurations have shown unique results for UV distribution doses. UV lamp performance efficiency. In case 1 clearly demonstrates the most even UVC dose distribution. Case 2 was similar to the case 1 except the irradiation field was a bit smaller. In case 3, the lamp configuration shows a non-uniform irradiation distribution. And case 4, the distribution is much narrower compared to the other lamp arrangements. UVC lamp performance conclusions. UVC irradiation works best when pathogens reach proximity of the radial distance of lamp surfaces. In order to achieve a higher UV dosage, the particles in the duct's airstream should follow a contour path close to the UV lamp surface. Facilities professionals can utilize UVC treatments to greatly reduce concentrations of pathogens. Discussions. Upgrading filters to higher efficiency ratings can cause pressure drops in the duct, causing a decrease in airflow velocities. In order to make up for this pressure drop, fan speeds must improve, causing energy consumptions to increase. In the HVAC industry, there are always concerns about energy savings as engineers implement methods to improve indoor air quality. As improvements like filter upgrades and UV lamps are applied, further research on proper delivery of constant airflow must be accurately be balanced in order to meet indoor design conditions. As research continues to progress, sensors and innovative devices can be studied to help create energy savings through physics while upholding the latest standards for indoor air quality. These are our references, and I would like to thank City Tech University, New York City College of Technology for giving us the opportunity to do this research project. And Barro, do you have any closing statements?
Yes, thank you all the professors. Thank you to our schoolmates, and especially thank you for Professor Kang for his help.
Thank you guys for this wonderful Cuny
you.
Research Scholars Program opportunity of 2021. And you guys take care. Thank you. Bye.
Thank you.